Okay, let us discuss. So, up to what we discussed means from introduction to magnetism in the human body are related to a current carrying conductor or the wire produces magnetic field. Okay, so we have seen that, we have discussed that, right? Current carrying wire produces magnetic field. Current carrying conductor produces magnetic field. So electric charges, electric current nothing but flow of electric charges, nothing but electrons, as we know, as we learned in the chapter electricity, current nothing but flow of negative charges. That flow of negative charges are called as electrons, So electric charges are in motion, produce magnetic field. Now what happened if these electric charges are in motion, or what happened if the electric charges nothing but current, nothing but current carrying conductor placed in a magnetic field, Before we discussed, a current carrying conductor or the wire creates a magnetic field. Okay, in which direction it occurred, in which direction it formed, how we form. So how the magnetic field is created, we already discussed. In case of straight wire, the we explained with the right hand thumb rule. The thumb rule is the direction of current, the curled fingers are the direction of magnetic field. In case of circular coil, so also we discuss with the right hand. The curled fingers are the carrying wire, the thumb denotes the direction of current, perpendicular to the knee. Then in case of solenoid, so like a bar magnet. Now let us discuss what happened. A current carrying conductor placed in a magnetic field. What happened means some force acts on a current carrying wire or current carrying conductor when we place in a magnetic field. So nowadays most of the people are using some LCD or LED TVs, right? But previously very long years ago, using small portable type TVs or CRT type TVs, crystal related some other, right? Small normal TVs, portable TVs, whatever. So while we are watching that portable type or normal, not LED or not LCD TVs, when we place our hand, we feel some sensation. When we bring a bar magnet near the screen of the TV, then what happened? The picture of the screen is distorted. When we remove the bar magnet from the screen of the TV, then the picture again come, right? So move the bar magnet away from the screen. Now you will see a great clear picture. So portable type TVs and old type TVs, when we place our hand, we feel some sensation. When bring a magnet near the screen, the picture is distorted. After removing the magnet, then again it gives a clear and perfect picture. Why I am telling this? Sir, we don't know that the kind of TVs, that kind of TVs. Then now, sir, we are using some LED, or LED TVs or LCD TVs, whatever. We don't know. Why I am taking this example? Because of TV, nothing but electrons, right? So, is the motion of electrons reaching the screen affected by the magnetic field of a bar magnet? That the screen nothing but simply motion of electrons, motion of electrons nothing but current only. So, motion of electrons are affected by a bar magnet. Bar magnet has a magnetic field. Due to this magnetic field, the electrons or the charged particles are affected. So, that is why the screen is distorted. Repeat this to confirm that the motion of electrons is affected to the field produced by the magnet. This must be due to the fact that the magnetic field exerts a force on the moving charges. That force is called as magnetic force. Means when a current carrying conductor placed in a magnetic field, this magnetic field applied some force on a current carrying conductor. So, a screen is distorted when we place a bar magnet near the TV screen. Magnetic field applied some force on the electrons which is reached near the screen of the TV. So let us discuss force on current carrying conductor placed in a magnetic field. We already know Oersted experiment. So shows that a current carrying wire produces a magnetic field around it. Since how can you say that a magnetic field created when we place a magnetic compass? We observe some deflection in the magnetic compass needle. Now, for this exactly reverse thing also happen. Means that is a magnet exerts a mechanical force, applied some force on a current carrying conductor, and if the wire is too free to move, this force can produce a motion in the wire. Means if it is a magnetic field, in this magnetic field, when you place any current carrying wire, due to this magnetic field, this current carrying wire experiences some force. So due to that force means a mechanical force is created on the current carrying wire, which is placed in the magnetic field. This is simple one. This force is equal and opposite force carrying wire. In 1821, Faraday discovered that Michael Faraday discovered that when a current carrying conductor, Faraday statement, when a current carrying conductor, current carrying conductor placed in a magnetic field, what happened the current carrying conductor placed in a magnetic field a mechanical force is a mechanical force is exerted. A mechanical force is exerted on the conductor, which can move the conductor. This statement is given by Michael Faraday in 1821. This is known as motor principle. Electric motor principle. This is also known as the electric motor principle. What is that? When we place a current carrying wire, a current carrying conductor in a magnetic field, it experiences some mechanical force. Due to this mechanical force, that current carrying conductor move. This is known as motor principle. Based on this principle, many electrical devices like electric motor and moving coil galvanometer are working. Okay, let us understand this force. Experiment to demonstrate the force acting, means mechanical force act on a current carrying conductor placed in a magnetic field. So the kicking wire experiment. Let us understand. Here just I explained the activity. I did not do because of all things are required. So understanding force on current carrying conductor placed in a magnetic field. So for that take a U-shaped bar magnet. Place a U-shaped bar magnet. So north and south. Right? Then here with help of a supporter, a current carrying conductor is suspended. And inserted in a small metal cap, or some other vessel that is have taken U-shaped bar magnet, the lower end surface shallow vessel. The small vessel. This small vessel is filled with mercury. Then other end, you have taken the other wire and connected with a battery. This the experimental setup. This is the experimental setup. Okay. Let's change it. I need to change it. Here place like this. So like this, a U-shaped magnet. U-shaped magnet is supported. Support shallow vessel. Mercury is filled. This is one end A and this is the another end B. The other end B is connected with another wire. Connected with another wire. So magnet B, okay, supporter T. So this is the experimental setup. This is the experimental setup. So this is this experimental setup is called as kick wire. Kick wire experiment. Kick wire experiment. Kick wire experiment. So take a U-shaped bar, U-shaped magnet N. So place like this. Here we have to take one more support for bar magnet. So we have to mention here. Then a wire is suspended through a supporter T. Then a wire is suspended here. The other end B is one end A, other one end is B. The other end B is connected with another wire which is connected to the battery or a cell. When we switch on, what will happen? Current is flow in a conductor. Current flow. So on pressing the switch, a current flows in the wire AB in the vertical downward direction. The wire AB is kicked in the forward direction toward the south, and lower end B reaches the position B dash, so that the wire comes to the new position AB dash shown by dotted line. When the lower end of B's hanging wire comes forward to B dash, it contact with the mercury surface is broken, due to which the circuit breaks and the current stops flowing in the wire. What happens in this experiment? When we switch on it, current carrier. So due to current carrying, the position of the wire AB changed to AB to AB dash, and this wire is kicked. This wire is kicked from the mercury. So mercury is a good conductor of electricity. So when we switch on it, electric current is passed vertically downward direction. Due to this, the position of the current carrying straight wire AB changed from AB to AB dash. So which breaks the bond, or it breaks the connection with mercury. Which break the connection with mercury, and the position of the conducting wire AB changed from A to B dash. Why? So let us know the reason. Right. Since no current flows in the wire, no force acts on the wire, in this position it falls back its original position. As soon the wire falls back, its lower end again touches the mercury surface, current starts flowing in the wire, and it kicks, and it is kicked again. that this action is repeated as long as the current is passing in the wire AB. It should be noted that the current carrying wire is kicked forward because a force is exerted on it by the magnetic field of the U-shaped magnet. From this experiment, we can conclude that when a current carrying conductor is placed in a magnetic field, a mechanical force is exerted on the current wire which makes it move. Okay. AB, since no current flows, when it is break the connection with mercury, it will suspend like this AB dash. So due to the magnetic force exerted by this, due to the no flow of electric current, it come back its original position again. And have a connection, and due to the current flowing, again it kicked away. Again it kicked away from mercury. Away from mercury means it breaks the connection again. So this happened. This movement of wire caused due to the magnetic field. Means magnetic field is produce some mechanical force. Magnetic field is produced due to magnetic field produces some force, a mechanical force on a current carrying wire. So the current carrying wire is moves from its original position. So once it moves from original position, due to no current flows, due to magnetic force, again come to the connection, current flows, again move, no connection, again come back. This happened like this. So this happened when a current carrying conductor is placed in a magnetic field. A mechanical force is exerted on the conductor which makes it move. So in the diagram, the current is flowing vertically downward and the direction of magnetic field is left to right, directed towards east. Thus, the current carrying conductor is at right angles to the magnetic field. Now, we have just seen that the motion of the conductor is in the forward direction towards the south, which is at right angles to the both the direction of current and the direction of magnetic field. Since the direction of motion of the wire represents the direction of force acting on it. The current is flowing vertically downwards. Okay. When the current is flowing vertically downwards, current carrying was straight wire. So what happened? In which direction the magnetic field is formed? So, clockwise direction, anti-clockwise direction. Clockwise and anti-clockwise. They are moving like this. So clockwise direction in the sense. So magnetic field is from left to right direction. Due to this left to right direction towards the east, thus the current carrying conductor is right angles to the magnetic field. So if it is the magnetic field, it is right angles makes 90-degree angle with the magnetic field. So it moves towards the south. It is the north pole and it is the south pole. It is the north pole or south pole. So what will happen? The current carrying wire. This current carrying wire moves. So moves towards the south pole. So current carrying conductor produces magnetic field. This magnetic field as left to right means towards the east direction. East direction means this side. So in which direction the current carrying wire moves? This direction. In this direction, which side is there? South pole of the U-shaped magnet. South pole of U-shaped magnet. So by simple, what you can say that explanation, unable to understand. Whenever we perform the experiment, it can easy to understand. So whatever it is, simple thing. If you understood properly or not understood properly, one thing you have to keep in mind, right? A current carrying conductor placed in a magnetic field. The current carrying conductor experiences some magnetic force or the mechanical force exerted by the magnetic field on it. Okay? Due to that magnetic force, there is some movement happened in a current carrying conductor. So this should be understand by doing, not simply by explaining. By doing a kick wire experiment, by doing the experiment, we can you can understand. Even I can understand by doing that. Simply just by explaining, a current carrying conductor placed in a U-shaped magnetic field. So when we switch on, current flows due to magnetic force. Current carrying conductor moves from its original position. So towards the north pole of the U-shaped magnet. So why it is moves? To move an object, we need to apply some force. Who applied the force here? Magnetic field. Due to the magnetic field, this current carrying conductor changes its position, means it moves from the original position AB to AB dash. Direction of current is vertical down. And the magnetic field direction left to right, clockwise direction. So direction is left to right, clockwise direction. Then in which direction it acts? East direction. So that's why the object means the current carrying wire moves from AB position to AB dash position. It moves towards the south pole of U-shaped magnet. So a little difficult to understand, but just keep in mind, a current carrying conductor is placed in a magnetic field. It experiences a mechanical force. Due to that mechanical force, then the current carrying wire moves from its position. This rule is stated by the Michael Faraday in 1821. So the direction of force acting on a current carrying wire placed in a magnetic field is perpendicular to the direction of current. In which direction it moves? This is the direction of current, vertically down. In which direction the object moves? Perpendicular. So direction. This is the direction of current, and the current carrying wire moves in this direction. So both are perpendicular to each other. And perpendicular to the direction of magnetic field. So if it is the direction of magnetic field, this is the direction of magnetic field to this magnetic field. So the wire or the current carrying move perpendicularly. So this is the direction of this is the direction in which moves. So the current carrying wire moves perpendicular to the direction of current, perpendicular to the direction of magnetic field. So maximum force is exerted on a current carrying conductor when only when it is perpendicular to the direction of magnetic field. So, if the current carrying conductor is perpendicular to the magnetic field, then the maximum mechanical force or the maximum magnetic force is exerted on it. So, no force acts on a current carrying conductor when it is parallel to the magnetic field. For example, it is the direction of magnetic field. If we place a current carrying conductor also in this direction, what will happen? No magnetic forces acts on a current carrying wire because the directions are same. Current carrying direction and the direction of magnetic field or the magnetic field lines are all in parallel. No effect is present. No magnetic forces acts on moving conductor to move the conductor. If the reverse direction of current in the wire AB so that it flows vertically upward direction B to A, then the wire swings towards the backward direction, towards the north. This means the direction of force on the current carrying wire has been reversed. For example, if the current is moved from B to A, then what will happen here? This wire move towards the north. So if it is vertically down, if the direction of current is vertically down, it moves towards the south pole of U-shaped magnet. If the current direction is top to bottom, is B to A, in this direction if you take, then the wire move towards the north. So because of current is like this, in case of current carrying vertically upward, magnetic field is from right to left, anti-clockwise direction. So due to anti-clockwise direction, this magnetic field moves the wire towards the north. In this case also we observe that the direction of magnetic field and the direction of current, so perpendicular to the current carrying wire. Means if the current carrying wire moves in this direction, the direction of moving current carrying conductor, the direction of current and the magnetic field are perpendicular to each other. In this case also perpendicular to each other. If in case of parallel, no magnetic force is exerted on a current carrying wire. Right? Let us understand. So let's understand the concept simply. A current carrying conductor is placed in a magnetic field. It experiences a mechanical force. Due to that mechanical force, what happened? Move the conductor. May move the electron, this current carrying conductor. In which direction the conductor move? Perpendicular to the magnetic field and perpendicular to the direction of electric current. This is keep in mind. So the vertically down and it move towards the east. Then vertically up and it moves towards the west. Means if you standing like this, I am the current carrying conductor. I am the current carrying conductor. Electric current is passed vertically down. In which direction the magnetic field is formed? Like this. Right hand. So magnetic field is formed around from left to right. Then similar this, right? So electric field is formed around myself like this. Then left to right. Left to right means is clockwise and anti-clockwise. Left to right. In which direction? So magnetic field is formed around me. Magnetic field is formed around me. Then in which direction I have to move? This direction. Right? So imagine that magnetic field conductor, due to magnetic field conductor moves this direction. So current carrying wire move this like this or like this. It is the original position. This is the original position. Due to current carrying, then what will happen? It becomes like this direction. If current carrying vertically up, then what will happen? I can move like this. So in this way. So what I have to understand, then I am explaining you. Then I hope you understand clearly. So top to means vertically down, move this side. Vertically up, move this side. Vertically down, the direction of current, magnetic field applied the force towards the left. Towards the left in the sense towards the right. For me, towards the left. For you, towards the right. Now understand. So if the current carrying conductor is vertically down, the magnetic field is formed left to right. Left to right. Here left to right in the sense your left, not my left, your left. When left to right, then the current carrying conductor move in which direction? Right direction. Right direction means for you right direction. If the current carrying vertically up, then the magnetic field is formed around the wire right to left. Then the current carrying conductor move towards left. Towards left means towards your left hand side. This is a quick wire experiment for understanding a force acts on a current carrying conductor placed in a magnetic field. So I hope you understand. Okay.